All right, today we're talking chemistry, and our first topic is redox. So, what is redox? Well, before we can really get into redox, we need to review some subatomic particles. First, let's talk about protons. Protons have a positive charge. They have a mass of 1 U or 1 atomic mass unit. They are found in the nucleus, and they are literally the same as the atomic number of an element. So, if the atomic number of an element is 6, and that element has 6 protons. If the atomic number is 53, then that element has 53 protons. And you can see protons with the positive charge located inside the nucleus. Neutrons, no charge, also a mass of 1 U or 1 atomic mass unit, and they are also found in the nucleus. So the nucleus is composed of 2 types of particles, protons with a positive charge and neutrons with no charge, which means no matter what, the nucleus itself has a positive charge. How much positive charge? Well, however many protons there were. 6 protons, the charge of the nucleus is positive 6. 1 proton, the charge of the nucleus is positive 1. Electrons. Electrons have a negative charge. Now they have no mass. Well, not exactly no mass, but we'll just call it no mass because it is so much smaller than a proton and a neutron. Electrons are found in orbitals outside the nucleus where they have an extremely high probability of being found. And higher energy levels or shells are further from the nucleus. So closest to the nucleus would be energy level number 1, further away, energy level number 2, and so on. These electrons in energy level number 1 have less energy than the electrons in energy level number 2. Okay, and electrons are moving rapidly in orbitals outside the nucleus. Then we have valence electrons. Valence electrons are in the outermost energy level or shell of an atom. And why are valence electrons important? Well, they are responsible for the chemical properties of an element. They are the only electrons that are lost, that are gained, that are shared, that are bonded, all those things. So again, in this illustration, this is energy level number 1 with 2 electrons. This is energy level number 2 with 1, 2, 3, 4 electrons. And since there is not an energy level 3, those 4 electrons in energy level number 2 are all valence electrons. In an ionic bond, electrons are transferred between 2 atoms. Which electrons? The valence electrons. So sodium has electrons in this lower energy level, but those don't matter. It had 1 valence electron out here. When it makes an ionic bond, that 1 valence electron leaves and is completely transferred to Cl in this case to make NaCl. Okay. In a covalent bond, also called a molecular bond, electrons are not transferred. They're shared. They exist between the 2 atoms. And covalent bonds can be polar or nonpolar. Hopefully some of that sounds familiar. We have polyatomic ions. So polyatomic ions are a little tricky in that the bonds within the polyatomic ion are covalent, but they have a charge. So when they bond, they form ionic bonds because of their attraction between cations and anions, between positives and negatives. Okay, so when a compound has a polyatomic ion, it has both covalent bonds in the polyatomic ion and ionic bonds between the ions. Okay. All right, now let's go on to the new stuff. Ready? Oxidation. What is oxidation? Loss of electrons. So you can see right here, Oxidation. See how this electron was here and it's over here now? So oxidation is loss. Loss of electrons. Reduction is gain of electrons. So you see how this electron showed up here? So reduction is gain. So the electron left here and went over here. So this one gained. So there are a couple ways to remember this. The first one is my favorite just because I love cats, any kind of cats. So it's Leo says grr. What do I mean by that? Leo, loss, electrons, oxidation. Leo, grr, gain, electrons, reduction. Leo says grr. But there's another way to remember it. You can pick the one that makes sense for you. This one is oil rig. What? Well, first of all, if you didn't know, that's what an oil rig looks like, or one type of oil rig. Ready? Oil rig. Oil. Oxidation is loss of electrons. Rig. Reduction is gain of electrons. Oxidation is loss. Reduction is gain. Okay, so you can pick the way that's easier for you to remember. All right, so we had oxidation, which was what? Loss. And we had reduction, which was what? Gain of electrons. Which electrons? Valence electrons. We put them together and we get oxidation reduction. Well, that is a whole lot to say, so we usually just say redox. Reduction with oxidation. Okay. They're most often single replacement reactions, so remember those when you have a single element on both sides. One substance is oxidized, goes through oxidation. One substance is reduced, goes through reduction. So you can see in this reaction, we have one that is being oxidized, going through a loss of an electron, and then this one is gaining, so one is being reduced, going through reduction. So in an equation, one thing goes through oxidation, one thing goes through reduction, one thing goes through reduction, one thing goes through oxidation. And remember, Leo, loss of electrons is oxidation, says grr, gain of electrons is reduction, or oil, oxidation is loss, rig, reduction is gain. Okay. Again, in a reaction, one thing goes through oxidation and one thing goes through reduction. Together, that makes a redox reaction. And we're going to learn a lot more about these. So that is just your introduction to redox. I hope you learned something new.